Hello everyone, welcome along to Space Dave Live. So we just had a few technical hitches getting on live today, so I think we're all going just in time. So it looks like we've got a couple of viewers, so hopefully everyone is happy. Are you guys happy over there? What we're going to do is we'll start off by showing you who we've got here, shall we? Okay then, so this is our live studio audience. Say hi everyone. Welcome along, and over in the back there we've got Jess and Floyd who are doing all our technical stuff tonight and helping out. So for some reason we are not seeing the live stream here, which is a bit of a nuisance, but I can see that apparently we have 5 viewers. So I really don't know what's going on there, but something must be working. So look, I tell you what, if anyone who's out there is listening, if you could just make a comment or something and perhaps even tell us how you found us, because we can't find our own live feed at the moment. Okay, oh, of course, no, we're actually having trouble. We can't even see our own comments at the moment, so that's a bit of a hassle, isn't it? Tell you what, Jess over there, you just keep trying and do your best, see if you can find out what's going on, and if anyone has got any ideas, perhaps you could email us or text us on the links along here, because we are somewhat in the dark as to what's going on. Anyway, that's such is the nature of live TV, and we will just carry on with what we're doing. So tonight we've got a few things happening. Let me just catch myself up on where we were supposed to be. See, all my prep that I was going to do in the last few minutes just didn't actually happen. So if we have a look here at our program tonight, this is more or less what we've got in mind. Yeah, I mean, you can see what we've got there. We're going to go through quite a bit of news. We've got a bit of news to catch up on this week. We may well not get through in the night sky tonight. If we have to can anything, that is the bit that we are going to can. Because we really want to make sure that we are talking about the black hole announcement. So that's the big thing in the news tonight. Now, of course, we did not have an episode last week. Apologies for that. Hopefully we didn't have anyone tuning in and wondering what on earth was happening. But as you probably know, as most of our followers know, last Wednesday was my grandmother's funeral, which is why we didn't have the episode last week. So I just wanted to say a very quick thank you to everyone who sent all your lovely messages through. Our whole family really did appreciate that. So this episode tonight is dedicated to the memory of Nana Dot, or Dorothy Saw. So she was very excited actually about what we were doing about the show. She knew what was going on, and so this episode tonight is in her memory. So let's just get on with things, shall we? Tell you what, let's start off with competition time, because we love competitions, don't we? So today, when I was thinking, what are we going to have for a competition tonight? I honestly don't know. So I decided, well, what the heck, let's have a competition to ask for suggestions for what would be a good thing to do for a competition. So that's all it is tonight. All you have to do is comment or email or text or whatever. So with the competition thing, we are looking for things that you can't just easily go and Google, right? So we're wanting to ask a question, what's some examples? Like, what's your favorite thing? Or what do you think a good reason for doing such and such or whatever? So something that you can't just Google, something you can participate in. Anyone who wants to send those suggestions through, that would be fantastic, and we will do a draw at the end of the night. So that's the competition. I think we need to keep things moving along, so we will head off to the news. Let's go and have a look and see what's happening in the news, shall we? We've got quite a bit of to get through, because of course we didn't have the show last week. So we'll start off with some local news. So this is quite a cool one, a very cool one actually. So North Hokianga could receive official World Dark Sky status. So we don't know if that's going to happen yet, but there are a bunch of official dark sky reserves and sanctuaries around the world. There's already one in New Zealand. Actually, the biggest one in the whole world is in the South Island of New Zealand. If we get another one here, that would be quite a big deal. So if you want to find out more about that, how all of that works, just go to darksky.org and you'll find out all about how the dark skies work. So it's still quite a long way away if it does happen, but it would be very cool if it does happen. In more New Zealand news, Rocket Lab, who we talked about last week, they had a launch last week. These guys are doing something interesting. They've just announced this week that they have developed or are developing their own satellites. Now, Rocket Lab, the New Zealand launch services company, is in the business of making rockets that launch, but this is quite an interesting idea. They are now talking about also making the satellites. So normally what happens is that a company, like an entertainment company or an internet service provider or someone, they will make a satellite that they want to put in space, and they will hire hire someone like Rocket Lab to put it in space. What Rocket Lab is saying is that they can actually handle making the satellite as well. So I think that's a fantastic idea. I'm not actually aware of any launch company, I suppose some of the big ones, Lockheed Martin and that, yeah, but generally speaking, the likes of SpaceX and stuff, they make the launch vehicles but not the payloads. That's the customer's thing, is to make the payload. So I think that's a really cool idea, and we'll look forward to seeing how that goes. So if you're interested in having your own satellite and you've got very deep pockets, there you go. Talk to the guys at Rocket Lab. Okay, let's get on with some other stuff. So this is about Mars, this one here. So it's just been announced that the first independent confirmation of a methane spike on Mars. Now you might be wondering, what on earth does that mean? You may recall, if you're interested in Mars or if you've been following the Curiosity rover, that some time ago, some years ago, it detected some methane on Mars, a big spike in methane, which is an important thing. We'll get back to that in a sec. But with anything like this, there's always a little bit of a doubt. Did they actually really detect the methane, or was it just a glitch in the instrument or some other anomaly? Well, what's happened is that Mars Express, which is a space probe orbiting around Mars, they've been back through the data from that and found that they also saw, or this probe also saw, that spike in methane. So that confirms that there was actually a spike. So so that's the first thing. The next question is, why? Why do we care? What's all that about? The reason that we're interested in methane, if we have a look at this graphic here, there are two things that produce methane that we know of, and that can be either just sort of natural geological processes, or it could be caused by life, microbial life. And of course, that's what we're interested in. Now the thing with methane is that it tends to disappear quite quickly. So if you've got methane in the atmosphere, it's coming from somewhere. It's not left over from something that happened a long time ago. Something is replenishing that methane. So it could be just something quite uninteresting unless you're a geologist, or it could be some form of alien life, which is what people like me are really hoping for. So I guess that's the first stage, is confirming that it was actually a methane spike. Much further down the track is trying to figure out exactly what it's all about and where it's coming from. By the way, if we just go back to this map here, what you're looking at with that big grid there is this is scientists' best estimates of where the methane could be coming from. So this is a terrain map of the area on Mars. This is where Curiosity was down here, if you can see that. And around here, this is kind of the area where they're thinking it's most likely to have come from. So that sort of helps them pin down, is there any sort of geological features there that may explain the methane. So we'll just leave that in the scientists' hands, and I can't actually see us getting much further with this for quite a while, but it is really interesting. That whole thing about finding methane on Mars is quite a big deal, really. Okie dokie, let's keep moving on. Look at this photo. This is awesome. This is a photo of an asteroid that I don't know how to pronounce. Perhaps someone could help me out with that. Actually, I'm sort of hoping that you guys at home will help us out with a few things. Especially today, because I didn't get a chance to do all the prep that I really wanted to. Normally I go and research how to pronounce these things. So someone tell me how to pronounce that asteroid. Anyway, the photo here is by the Japanese space probe Hayabusa 2. And you can actually see, can you see it there? See that? That's a shadow of the actual space probe itself when it took that photo. So that's pretty neat. But what's happened is that the Hayabusa 2 has actually fired a projectile at the asteroid. They like to do this sort of thing, eh? There's a fair bit of destruction going on in space, but it's only a little thing. Look, I mean, the whole asteroid is pockmarked with things hitting it. So what it's done is it has fired a projectile towards the asteroid. It's hit the asteroid and made a little bit of a crater, and the idea is that it blows a whole lot of stuff up into space, and the Hayabusa 2 is capturing some of that stuff for a return sample mission. And that's a big deal indeed, because there's only so much you can learn by going out there and looking at it and analysing it. We really actually want a sample to come all the way back to Earth. So the idea is that it will capture some of that stuff out of that crater that it's made and bring it back for study. So that's going to take quite a while. I'm not sure when that's due to get back to Earth, but it won't be for years, I wouldn't think. Again, if someone can tell us exactly when it's expected back, that would be very cool. Now let's just pop over to Jess. Are we having any luck over there, Jess, with finding our comments and things?
Yeah, I've found everything's working.
Everything's working well. Awesome. Thank you, Jess. So is anyone commenting so far?
Yeah.
Okay. You just let me know if there's anything important, that we need to know about.
It said Ryugu.
Ryugu? Ah, okay, thank you very much. Now I am trying to bring up the comments so that I can see them over here so I can interact a little bit better. We've got another comment over here. Yep.
I think it's Ryuga.
Ryuga, you think? Okay, thank you very much for that. Okay, so I should have known that, shouldn't I? It's a bit remiss of me for not catching up on all this stuff. Okay, that's enough about that one. Let's have a look at this, another really cool picture here. I like this one. This was taken by an amateur astronomer, George Hall. Now what you're looking at there is an impact on Jupiter over there. You can see it there. That is very awesome. And this is a really good example of how amateur astronomers can really help out. In fact, amateur astronomers are a big part of astronomy. A really cool thing about being into astronomy is that it's one field where the amateurs can absolutely participate and be as important as the professionals. And I've been lucky enough to mix a lot with professional astronomers, and they take the amateurs absolutely seriously because they know they are a really important part of what they do. And part of that, of course, is that you've got astronomers all around the whole world with telescopes pointing at the night sky all the time. The professionals can't do that, so they actually, to some extent, will rely on amateurs to be pointing out things like this when they happen. So George must have been very happy with himself to have captured that impact. Good on you, George. Well done. This news isn't so good. That CGI image there is the Wide Field Infrared Survey Telescope, which is supposed to be being developed and sent off into space, but unfortunately it looks like the funding has been cut for that. We don't know for certain. It was in the President's budget request to not fund it, so we'll see what happens there. Not completely unexpected that it's been cut, but yeah, it is quite a shame. These sort of missions are really, really important, and we really should be funding those, I think. And this is, well, a lot of the blame is being laid at the James Webb Telescope, which is like way, way late and way, way over budget. Sorry, could you just shut the door there? Thanks. Thank you. It's just getting a little bit loud outside. Sorry about that. Anyway, what was I saying? Oh yeah, so the kind of blaming the James Webb for going so far over budget, but it also doesn't help when you've got all of these really expensive human spaceflight things happening, and we talked at length about that in the last couple of shows. So a lot of the money does tend to get sucked up there, and a lot of astronomers are quite rightly upset that lots of money is being sunk into things like the SLS, which we've talked about a lot, and things like this are being defunded. It's pretty tough, really. Anyway, that's that. Back to rockets. Look at this one. Falcon Heavy. Now you remember this? Falcon Heavy is SpaceX's big heavy launch vehicle. It's only ever launched once, and that was a year ago, just over a year. Oh, I've got the date here somewhere, haven't I? Yeah, just over a year ago. Remember, that's the one that had the car in it, where Elon Musk sent his Tesla car into space, and it was quite a hoot, really. But it's only ever launched once. It's due to launch again tomorrow. If you want to watch that, go and look it up on SpaceX's feed. It's about 10:30 New Zealand time tomorrow. So this is the first commercial launch of the Falcon Heavy. So that's something well worth watching. It's an amazing rocket, that one. Now also from SpaceX, we have been talking a lot about its BFR or Starship, whatever you want to call it, their next generation, which is going to be even more powerful than the Falcon Heavy. And you may recall last show we were hoping to see some tests from this rocket. It's being built out in the open, and everyone's trying to get a glimpse of it. So we had the live webcam, didn't we, last time, that we were trying to show you that. But if you didn't, well, you probably wouldn't have managed to see it live. But I've got a quick video here that Elon Musk has shared. So let's just roll this. It's not much of a video, but you can kind of see it there. That's it in slow motion. So that's the test. Now what's happening here is that this is the Star Hopper, the short version. I'll just pause it there. So yeah, this is the short version of that whole rocket, and you can see it's just got one engine on it at the moment. The next version is going to have 3, but this is it being tested. So that's the test that we were all waiting for. Now this is a tethered test. Or a hold down test. That means that the whole rocket is being tethered and held down so it doesn't actually go anywhere. They're just testing the rocket out. So you can sort of see it in slow motion there. Now this is more of a big deal than you might think, because once they've got to this point where they're able to test the rocket engine attached to the rocket and everything, they're also in effect testing out all the other plumbing and everything that goes with it. So there's a whole lot of stuff being tested there. So it's all looking really good. This is going to be just an amazing vehicle if it ever does actually properly get off the ground more than a few inches. Elon Musk, I think, is hoping to launch this, is it late this year even, or early next year? But of course, Elon Musk is prone to being extremely optimistic. So anyway, that's what's happening with the Starhopper. It's all looking pretty good, really. Not so much for poor old Boeing. So Boeing is a competitor of SpaceX, and they are developing a new rocket called the Vulcan and a new capsule called the CST-100 Starliner, and it's been delayed again. So I guess not too much of a big deal, but this will be annoying the folks at Boeing because SpaceX is getting pretty close now to being able to launch people in theirs, and Boeing is still not really getting off the ground with theirs. So a bit of a hold up for them, but hopefully we'll have some luck later in the year. Okay, now you remember this one? This is the Bereshit moon lander. This is the Israeli private organization actually that's sending a lander to the moon. We've talked about that in previous shows. It's taken a long time to get to the moon because it doesn't have any people on it. It doesn't need to get there quickly, so it can go very slowly, but it has now entered lunar orbit, so it's orbiting around the moon and getting ready to land, and that is also due to land within the next couple of days. Not sure of the exact time, but this is a big one to keep an eye on. This would make them, yikes, I think the 4th country or agency to put something on the moon. Not entirely sure of that, but anyway, it's the first private one, definitely the first private lunar lander. Now I believe this was actually part of the X Prize program that Google was sponsoring a while back. They missed the deadline, but they decided to carry on with it. So all the best to you guys. I hope that really goes well in the next few days, and we will definitely report back next week to see how that went, because one way or another, I would say it's going to end up on the moon. The question is, does it end up on the moon in one piece or not? So we will report back on that. What else have we got here? Well, here's more about the moon. I keep going on about the moon, don't I? Because it's all on for young and old when it comes to the moon. I've been saying for a while now that we're on the verge of another race back to the moon, and it really is hotting up now. So there's a German company called PT Scientists, and they are planning to launch not just one, but regular lunar landers to the service, and they're going to be providing this as a service. That's the plan, so you can just book a lander to the moon if you like. So this is a CGI image of what they're hoping to do, and I noticed on here what has been coming for a long time and is now finally with us, and that is sponsoring stuff in space. So I expect to see that become a much bigger part of all of this. Interestingly, I think previously sponsorship hasn't really been worth it for big space programs because they're so expensive. Any kind of sponsorship isn't really going to contribute that much, but now the costs are coming down a lot. Sponsorship can actually make up a more reasonable amount of the cost, so I expect to see a lot more sponsorship in space. I'm quite happy with this kind of thing, but as you know from a rant I had a couple of weeks ago, I am not such a fan of things like putting big gaudy things up in space that you can actually see from Earth. I think that's terrible, and I hope we don't have that happening. What else have we got here? Another failure. There's a Chinese outfit called One Space. They were attempting China's first privately funded orbital rocket, but unfortunately the second stage failed, so that didn't really happen. I believe they're going to keep trying, so good luck to them. Space is hard. We expect to lose a few when you're first starting, so give it another go. I hope you bounce back. Good on you. Another space story, there's not really any images or anything to go with this one, but I just came across a report, which was almost a throwaway line in a video, about this Russian, I spelled that wrong, didn't I? Whoops. Sorry about that. A Russian corporation called Energia are developing a space washing machine, or a washing machine for in space. Now that's a much bigger deal than you might think, because it turns out that the washing machine, there's no washing machine on the space station. They've never been able to make one that actually works efficiently and does the job properly. So their clothes are actually disposable up there, which is, obviously you don't want that. So they're trying very hard to make a washing machine. It's not the first time anyone has tried this. This is a story going back to 2011 where NASA said that they were on the verge of building a washing machine, and it still hasn't happened. So that gives you an indication of how hard it is. Funnily enough, two of the most difficult things it seems about having people in space is making a washing machine three things actually: a washing machine, a toilet, and a shower. So they all seem to be very difficult. And at the moment, they are trying to make a new shower on the space station. The toilet, they finally got going properly, but it took years and years to get the toilet right. And I think they were probably very relieved when they finally did. You don't even want to know what the early toilets were like in space. I think it's a stretch to call them a toilet, actually. Anyway, we won't go there. The details are a little bit gnarly. What else have we got? I quickly wanted to mention this. There's a publication that NASA puts out once every year called NASA Spin-Off, and it's just been released, the 2019 version. What this is a magazine that talks about all of the spin-offs that have come from the space program in the last year. And it's quite fascinating reading because they can do it every single year, and every year they can list a whole bunch of things that we have here down on Earth that are thanks to the space station. And I believe they're up to about 2,000 things that they've covered since they first started doing this back in the 1970s. So space is providing us with all sorts of cool stuff down here on Earth. And I think it would be really good if more people sort of understood and appreciated that. So it's pretty easy to find. If you're interested in looking up NASA, reading the magazine, just go and look up NASA Spin-Off. That's fairly easy to find. Now in the actual real news, we've just got one more story here which cracked me up. I loved this one. You will remember a little while ago when I did a rant that I was just talking about before. I mentioned this obnoxious monstrosity here. This so-called self-styled artist put this thing up into space, and it was this enormous reflective thing that's supposed to unfurl in space and make a light as it shines across the sky, and I absolutely hated it to bits. But what's happened is that when it launched, they didn't actually have permission from, it must be the FAA, I think it's the FAA and the FCC. Yeah, anyway, so they needed permission to be able to unfurl it in space, but they didn't have that permission when it launched, and I believe that's because of the United States government shutdown. So at the moment, it's up there orbiting around and around, but whoever has to give permission for this has got such a big backlog because of the US government shutdown that they're just not catching up, and they haven't got permission to unfurl it. So I'm very happy about that, and quite frankly, I hope the whole thing crashes and burns without ever unfurling, and all their money and efforts have been completely wasted. I would be very, very happy about that. So there you go. Righto, so anyway, we always like to wrap up the segment with a little bit of fake news. So I've got just a couple of things here. And to be fair, as normal, it's not so much fake news, it's more sort of misleading headlines and stuff. In this case, it's the good old space elevator, and the headline that keeps getting rehashed every time someone talks about the space elevator: it's just around the corner. We're just coming into the age of space elevators. It's kind of like nuclear fusion reactors. You know, economic fusion reactors are 20 years in the future and have been 20 years in the future for about the last 60 years. It's just one of those things that we're never quite getting there. So I think, what does it say? Elevator to space could be going up sooner than you ever imagined. No, it's not. That's all I'm going to say about that. It's not happening anytime soon. One day it will happen, but I don't think it's happening anytime in the foreseeable future. So the space elevator is one of those things that it just gets misreported on terribly all the time. But it is a fascinating thing if you want to go and look it up. One other quick thing here. I saw this interesting thing. Turns out Mercury might actually be Earth's closest neighbouring planet. Well, that's a weird thing. How can that be? Turns out it's not. But there is something to it, actually. What they're saying here is that as the planets orbit around the sun, so you've got the sun in the middle and all the planets orbit around and around. Of course, Mercury is the closest, going around the sun. Earth's a bit further out. You've got Mercury, then Venus, then Earth. Turns out that as they all orbit around, when you take the average distance that each of these planets is from the Earth, it turns out that on average, Mercury is actually closer to us than either Venus or Mars, because those ones go a long way around the other side of the sun. So they spend a long time a long way from us. So on average, they're actually further away, which is interesting. I didn't know that. I don't know if anyone's actually ever done the maths on that before. So it is an interesting thing. But as for whether you would call that making Mercury, what do they say, closest neighbouring planet? I don't really think that quite stacks up. I guess it's a case of how you define it, really. But honestly, I think Venus and Mars are our neighbours, and I think they've got that wrong there. Anyway, as I say, there is actually genuine science behind the whole thing, and it was sort of mildly interesting, I think. Right, how's our time going? So we definitely, in about another 5 minutes, we want to be talking about the black holes. So we can either, I think what we might do actually is, maybe I will fit in a quick rant here. So yeah, let's talk about this one. This will be a fairly short one, but sometime in the last couple of weeks, it must be about 10 days ago or something, this happened. This is India. Righto, so I've been a big fan of the Indian space program for quite a while actually. I've been talking them up. The Indian Space Agency has been doing some really, really cool things in space, including getting a robotic space probe orbiting around Mars, which is a really quite an achievement. It's something quite special really. It's still going there now, and they've just been slowly and steadily making really, really good progress. So I've been loving what the Indians are doing until they did this. So what they've done is that they have launched a ballistic missile defense. So essentially what's happened, in fact I've got a graphic that kind of shows it here. So one of their own satellites, at least it was one of their own, is orbiting around the Earth, and they've launched another missile to intercept it and blow it up in space. Well, you can imagine how I felt about that, because most of you know how I feel about militarizing space. I'm not a fan of it at all. I've got a quick video here that was provided by the Indian Space Agency. This sort of shows you a little bit of the launch and what they are saying happened. So you can kind of see it going up there. This is obviously just a CGI image. So what they're doing is that they're testing anti-satellite technology. And I think the video here goes to show, yeah, here you go. This is what they think it looks like when it happened and blew it up. Boom, that's the end of that. Well, look. First of all, it wouldn't have been anywhere near that clean. That video kind of shows it just sort of destroying, and that's the end of it. But of course, as we know from the 2007, I think it was 2007 Chinese experiment doing exactly the same thing, what it does is it creates a vast amount of space junk. This one's not as bad as the Chinese one, but it's still bad enough. Now the Indians, let's see, the Prime Minister said this: India has always been against arms race in space, and there has been no change in this policy. This test of today does not violate any kind of international law or treaty agreements. Well, first of all, they went on to say that it wasn't going to create any long-term space junk because it was low enough that it would all come back to Earth very quickly. That turns out to not be the case. It turns out that there's a whole lot of stuff that's going up to was it 2,000 kilometers in orbit. Well, that's high enough into orbit to be staying there for years and years into the future. So straight away, they've just added a whole bunch of stuff to the space junk out there, which is appalling in its own right. I just cannot believe that any country would willingly do that. And the other thing, of course, is it is an arms race. I mean, what is this guy thinking? You know, we're against an arms race. This is an arms race. That's exactly what you're doing. And now everyone else feels that they've got to catch up and be able to do the same thing. What I'm actually picking is that they are positioning themselves here so that if there ever is a treaty in the future, they will be in the haves rather than the have-nots, and that will give them some more bargaining power, which to me, oh, it just grates me. Oh, it makes me really, really angry, this stuff. You know, this is something that I can really rant about, because we should not be doing this, right? We've got space up there at the moment which is relatively clean, relatively free of militarization, and now is the time to stop it. But what's happening is that the general public doesn't even know it's happening, really. We see the odd story like this, but it just keeps happening, and it shouldn't be, and I think we should be doing something about it. It's really hard to know what we can do about it, but here's a start. This is the Indian High Commission. This is their Facebook page. Go and find them on Facebook and give them a rev up. Tell them exactly what you think about it. So I've done it already. Be polite. If you're going to do something like this, you've got to be polite, be respectful, explain why you think it's a bad idea and why you really wish they would do something else with their time. So For me personally, it's mostly about the militarization of space. I think now is the only chance we are going to get in human history to stop this from happening. And we need to mobilize. We need to do something about it. And the other thing, of course, is that space junk issue, which is just absolutely terrible. That's enough of a rant from me. I think we will... Oh, sorry, we've got comments from out in the audience there. What would you like to say?
I just wanted to know, are there any countries that currently have weapons in space?
That is a really good question. Are there any countries that currently have weapons in space? Well, so there are international treaties governing this kind of thing in space. Now, as far as I'm aware, there are no countries that actually have what you would call a weapon in space at the moment, but it has been done in the past. Unfortunately, I didn't really have time to bring up any graphics, but I know the Soviets and a couple of others have actually proposed and possibly tried having weapons in space. Mostly, it's actually more about surveillance and that sort of thing. So the various militaries from around the world certainly do have assets in space, but it's mostly about surveillance. As far as we know, they don't actually have any weapons. So when you think back to the United States Star Wars program, Ronald Reagan's thing, that just didn't really work. It turns out that having missiles in space pointed back down towards the Earth, that doesn't really work very well. It's not a great idea, it turns out. It's more, I think, when we're talking about militarizing space, we're probably talking more at this stage of taking out satellites. So, and that is a big deal. I mean, if you're in the military, then being able to take out another country's space surveillance systems and GPS and stuff like that. I mean, imagine if you just took out the GPS system, that would be a big deal if you are at war with someone. So that's mostly where we're at the moment, is looking at surveillance systems and other stuff like that and being able to take them out. So the treaties that we have at the moment, as far as I'm aware, only cover weapons of mass destruction in space. So the Indian Prime Minister was kind of technically correct when he said that it does not violate any international law or treaty agreements, because we don't actually have anything covering this type of system at the moment. And I think we should. I think it's high time that we said it was, we made international laws to stop people from doing this sort of thing. I mean, even aside from the military applications, the amount of space junk is just outrageous. And the idea that these guys are putting hundreds of more bits of space junk up in space when we're all trying to clean up space, it just rankles me so bad. Also, NASA Administrator Jim Bridenstine, I didn't say what he'd said before, so he came out and said, this is a terrible, terrible thing. And he goes on to really serve it to them. So, you know what? I wasn't really a big fan of Jim Bridenstine before he was made NASA Administrator. And I wasn't actually that happy. I won't go into all the reasons why, but I have to give him credit. He has impressed me a few times recently, and I think he did a really good job of coming out and just being quite unequivocal about this. So good on you, Jim. Yeah, you might be a twit in some other ways, but I think you're getting some things right on the mark. So good on you. Righto, are we happy with that? Anyone got any other questions or comments about this? Okay, we'll keep moving on, shall we? Because our time, oh look, it's 7:30 and we really need to be talking about the black hole. See, I don't think there's anything else that we have to cover before that. So let's talk about the black holes, shall we? So, as you may have heard, tomorrow morning New Zealand time, there's going to be a really, really big announcement. Actually, sorry, before I go into this, can I just check, has anyone else got any comments or anything we need to cover before this? Thanks for that, Jess. Right, so the competition, we so far, if we count up all the entries we've got for the competition so far, it comes to 0. So if you would like to win a prize, now's the time to get in. Now, unfortunately, I don't know what the prize is going to be tonight because I didn't get time to make one, but over there in the background you can see our shop. We've got a space shop there. So look, off the top of my head, what I'm going to do is I'm going to say a $25 credit in our shop, and you can actually go to spaceshop.nz. I think that's our shop, isn't it? Our online shop. So go there and you can find something there, and we will ship that anywhere in the world. So if you want to make a suggestion about what competition topics we could have in the future, and we are looking for questions that you can't easily Google. Right, so we want questions to ask people. It could be your opinion about something or your prediction of something or whatever. Just give us any suggestions for what we could do for competitions. And at the moment, you've actually got a pretty good chance of winning. So you guys in the audience are, of course, also welcome to participate in that. Righto. In fact, I'll tell you what, I'll come back to you guys a little bit later and see if anyone's got any suggestions for what we could do for a competition, because we do need to draw that tonight. And we will, of course, draw it. Jess has got the astronaut helmet down there. We put all the names in a helmet and we pick out a winner. Right, back to the black holes. Okay, so in the morning, what's happening is that astronauts are going to be releasing the very first actual photo of a black hole. Wow, that is really cool. So look, let me just start by showing you this image here. This is a computer generated image. Oh, look, I haven't put my little CGI thing there. I'm really trying to make a habit of putting a little CGI note on anything that's not a real photo, because it's getting harder and harder to tell the difference these days. This is an image that I use when I talk to schools and give other talks about black holes and things. This is a computer generated image of what we think a black hole might look like if you could see it with your own eyes. Now, this is not the kind of photo that we are expecting tomorrow. And it's a little bit complicated and it's a bit hard to talk about, so bear with me while we work through this. So first of all, the announcement is that there's going to be a photo of a black hole. Now, it's not really going to be a photo in the traditional sense. It's not the kind of photo that you would take with your phone if you were out in space floating around and you wanted to snap a picture of the black hole. It's not that. It's actually being taken by this. We call it a telescope. It's called the Event Horizon Telescope. Now, it's a bit tricky, this one, because it's not what you would normally think of when you think of a telescope. First of all, it's not a single telescope. It's actually, was it 7 or 8? 1, 2, 3, 4, 5, 6, 7, 8 telescopes around the world, and they are radio telescopes, not normal optical telescopes. Now, bear with me while we just work through this little bit here. So, if you're familiar with the electromagnetic spectrum, that's all the different kinds of light that you can have. So what we see with our own eyes is a small part of the electromagnetic spectrum in here. That's what you can see with your eyes. There are other kinds of light, for example, infrared light and ultraviolet light. We can't see them because our eyes just can't. Some other animals can see a bit of infrared or UV, but we can only see that little bit in there. However, radio waves, microwaves, X-rays and gamma rays are also part of that spectrum. So they're made of photons. Yeah, let's not go into all of that. That gets a little bit too heavy. But really, all of those things there are all effectively different colors of light. So that's a weird thing. Radio waves can be thought of as a color of light, just a kind of color that you can't see. In the same way that there are some frequencies or wavelengths of sound that we can't hear. They're too high or too low. Same thing with light. Some frequencies are just too high or too low for our eyes to see. So we see in that visible range. What's happening with this photo of the black hole is it's actually going to be taken with those radio telescopes. So instead of looking like a normal telescope in visible light, they are looking in radio waves, sort of in this band along here. So do you still call that a photograph? Well, it's all still photons, so photograph, yeah, photo comes from photon. So yeah, I think technically you can call it a photo, but we just want to be clear that it's not like a snap photo that you're normally taking. Now, I'm not actually sure what frequency range they are looking at. My best guess is that it would be around about here somewhere, but certainly in the radio range somewhere there. So if we just go back to that other picture, you can see these are big radio dishes. So that's what they're doing. They're collecting radio waves from out into space, and they are making that into what they're calling a photo. So there's a couple of things to bear in mind there. First of all, any colors that you see are not going to be real colors. They're going to be converting those images from the radio waves into colors or frequencies that we can see. So what is it actually going to look like? Well, that's a good question. We actually have no idea at all of what it's going to look like. So my best guess is that it's going to look something perhaps a little bit like this. I honestly don't really know, but I'll tell you what I want to do is I want to show you the website. Let's go and have a look at that. So this is the Event Horizon Telescope. Bear in mind that we call it a telescope, but it's actually a whole lot of different telescopes joined together. There's a lot to talk about here, eh? It's quite a complicated topic. Actually, look, I'll tell you what I'm going to do. I'm actually going to step back a sec, and I'm going to show you my picture, or not my picture, my globe. It's one of my favourite props that I keep getting out. So What happens when you're trying to take a photo or an image of something a long way away? You are very much dependent on the diameter of your telescope. Optical telescopes, you really just, it depends entirely on how wide your lens or your mirror is. When it comes to radio telescopes, it works a little bit differently in that you don't have to have one big wide dish. You can have one dish over here and another dish over here, and you can sort of join them together into one image in this way that you can't really do with optical telescopes. So with the optical telescope, you are really limited by the diameter of your lens or mirror. With a radio telescope, you're limited by the distance between the two dishes. So what you want to do is you want to have as many dishes as you can, spread as far apart as you can. Actually, it does get a bit more complicated than that. You actually want a whole lot of different ranges, but essentially your resolution is going to be limited by the distance between them. So what they do is that they get different radio telescopes all around the world, so you can effectively make a telescope as wide as the Earth. So that's a really, really big deal, obviously. So that's why we've got all of these telescopes, radio telescopes all around the world. And what happens is that they're not actually linked together in real time. They all take the photos or gather the data at the same time. In effect, they gather so much data that it can't all be transmitted across the internet. Each one of these dishes records the data on its own, and then it has to be loaded onto hard drives and flown all to the same place where they can then try and put it all back together again. So that's kind of how they're doing it. So they're taking it in radio wavelengths, and then they're joining all the pictures together. What this also means is that even though you can put a picture together out of all of these, you do have to kind of, well, they use an algorithm to fill in the missing pieces. That's a whole complicated thing in itself. But if you're really interested in how that works, there's a great TED talk by Katie Bowman, who talks about exactly how that works, and it's called interferometry, and it's quite a technical thing, I guess, but if you're interested in that, go and look this one up, because she explains very well how all of that works. We're not going to get into all of that detail right now. What I want to do is I want to show you the website that we're talking about. So this is the Event Horizon Telescope website. They've got a whole bunch of really cool resources down here, except that video there. Do not watch that video. Because it's the dumbest video in the history of video production. It's a whole lecture, an hour-long lecture of guys talking about what's on the screen over there that you can't see. It's bizarre. Anyway, so apart from that useless bit of non-information, if you go up here and you look in resources and go over to simulations, what we've got on this page is a bunch of simulations of what they would expect to see. This is looking at the black hole in the center of our galaxy. Okay, so don't worry about that just for now, but I want to show you down here. Let's have a look at some of these simulations here. Excuse me while I just grab a drink. So let's see, we probably haven't got time to look at all of these actually. This is quite an interesting one. Actually, I'll just quickly show you this one. This shows you a black hole, which we might come back and have a look at shortly. But this shows you those funny looking lines and everything around there. They are magnetic fields, magnetic field lines. So if you're interested in how all of that works, and we might come back to that, it shows you how all the magnetic field lines around a black hole get really, really distorted. But I actually wanted to show you some of these simulations here. This is a cool one. And let's just full screen that, and we'll play this video. Now this is a simulation. I'm sure you will all recognize this as a general relativistic magnetohydrodynamics simulation. And it's basically looking in radio wavelengths at a black hole. We really don't have time to go into all the details there, but I'm showing you this because I think this is most likely the kind of photo that we're going to be looking at. So I could be way off here. It'll be interesting to see in the morning how close I was, but I'm picking that it's likely to be something like this. So you're looking here at the black hole is kind of this part in the middle here, and what you're seeing around the edge is an accretion disk or stuff that's going around and around and being sucked into that black hole. So I'm picking that, let's just pause that the image could well be something sort of like that. I would doubt whether it's that sharp. I'd expect it to be a bit more blurry than that, but it's going to be something like that, I think. Remember, the colors don't mean anything here. That's just colors that they've put in here. In this case, The brighter colours are the ones that are coming towards us and are brighter, but we don't need to worry too much about that now. So that is my best guess as to what the photo might look like tomorrow, but we will see. And what I'll do is I'm pretty sure the press conferences, actually look, let's just quickly talk about this, because the press conferences are going to start at about 1 o'clock in the morning New Zealand time. If that's not a time that suits you, fear not, I'll be probably doing an all-nighter tonight. I'll certainly be up very late watching the press conference, and I will share it on our Facebook page so that you can swing by in the morning and have a look at it. But if we look here, somewhere down here, if we click on these, it tells you all the different places you can go and view the press conferences online. Now you may have to search through a few of them to find one that is both in English and operational. I found that about half of them are only one of those things or neither. So anyway, as I say, I will update our Facebook page in the morning and show you what the photos actually look like. In the meantime, let's go back and talk about which black hole that they might be trying to image, and then I want to talk just a little bit actually about black holes. In the meantime, do we have any questions about black holes or anything that's going on here?
We've had one person ask, is it going to show here?
Sorry, what was that again, Jess?
Is it going to show here?
The press conference? Okay, so look, thanks for that. The press conferences are just online, so sorry if I'm not catching the drift of your question there, but if you're asking if the press conferences are going to be shown here, yeah, you just need to go online. They're doing about 6 different press conferences simultaneously around the world and in a few different languages, so you just need to go to their website there and see if you can find one of these ones. Just click on a few links there, and that's what I'm going to be doing, and hoping that I find one of them that is in English. So, well, obviously at least one of them will be, but anyway, so that's how you see that. You go and have a look at it online. Now, where were we? We're talking about which black hole, because at this stage we don't even know which black hole that they are talking about. Sorry, Jess, hang on a sec, let me just come back to you there. What have we got?
Do you think the photo will show at an event horizon?
Ah, what a great question. Who's that from?
Caitlin Ward.
Thank you, Caitlin. That is an excellent question. I'm impressed, actually. That's a really cool question. Do we think that the black hole is going to show the event horizon? Let's look back at the photo here. Let's just assume that it looks something like this. The short answer to your question, Caitlin, is no, we don't expect to see the event horizon. So the event horizon, the event horizon is the point around a black hole. It's not actually a physical thing, but you imagine you've got the black hole in the middle, and then as you get closer and closer to it, the gravity is going to get stronger, and there's a point around, or a sphere around the black hole called the event horizon, and once you pass over that event horizon, that's the point at which there is no turning back. Yeah, once you go through the event horizon, that's the end of your day. You're going into the middle of the black hole, and everything is going to turn south for you very quickly. So don't do that if you're ever out in space. So the question is, are we actually going to see that event horizon? The answer is no, because what we are seeing here is the accretion disk, or all the stuff being pulled into the black hole. Now, I should have mentioned this first of all probably, but there's just so much to talk about. I'm just all over the place here. But it's very hard to take a photo of something black in space, isn't it? Even whatever wavelength you're talking about. So what we're actually hoping to photograph is not the hole or the black hole itself, it's all the stuff going around and around falling into it. And the black hole will be the dark spot in the middle that you can see there. But the event horizon is smaller. So all of the stuff here that is circling around and being dragged into the black hole, that is sort of around quite a way actually from the event horizon. I'm not sure where the event horizon would be in this image, but I'm picking it's likely to be something much smaller, perhaps even smaller than that even. Someone correct me if you know. But so we won't actually see the event horizon itself, we will just see the stuff going around and around it. Now, you might even see some stuff that appears to go in front of the black hole, which would seem a little bit weird, but that could be because we're seeing some things in front of it that are also generating light. So, good question there. What we really should do, actually I'll tell you what, we'll go back first of all and talk about which black hole we think we might be looking at. There are 2 main candidates. Although we don't know which black hole it's going to be, there are 2 candidates. One of them is in the Milky Way here. So this is our galaxy that we live in. So our solar system, the sun, all the planets and everything else is one tiny wee little dot somewhere in there. And all the rest of the stuff here is something like about 200 billion other stars with their own planets and stuff. And that is the Milky Way galaxy. This image is a computer generated image looking at it sort of face on. The one on the left here, that is an actual photo of another galaxy that we think is like ours, as you would see it side on. So that's what our galaxy looks like. And you may know that right in the very middle of our galaxy is a supermassive black hole. And we are essentially orbiting it. Technically it's not, but essentially we are traveling around and around the black hole like that. And so you could say that we are all orbiting that black hole right now. So right in the middle is this supermassive black hole. It's called Sagittarius A star, and I think that's probably the most likely one that they are going to try and image. So it could be that one, and if you hear the name Sagittarius A star, it's actually spelt Sagittarius capital A asterisk, but it's pronounced Sagittarius A star. Weird, I can't even remember why that is. But anyway, that's one of them. The other candidate, I think, is in another galaxy, like the Milky Way, but somewhere else. Actually, galaxy M87, I think it is. Someone correct me if I got that wrong. I think it's M87. And the other candidate is the supermassive black hole in the center of that galaxy. Why that one? Because its supermassive black hole is much, much bigger. So this one is obviously much closer in our own galaxy, but the other one is also a candidate. It could be both, actually. They could have done both, but I'd sort of be surprised. I would imagine that they would just concentrate on one and release that first. So that could well be what we are looking at there. So what I might do, just quickly, actually, I'll tell you what. No, I will. I'll show you this video that we've got here. Let me just bring that over. So first of all, we are looking at a time-lapse video here. This is looking towards the center of our galaxy. Now what you're seeing there, I'll just pause it. This is a whole bunch of the stars that are right around the center of our galaxy. If we look at this picture here again, this big bulgy bit in the middle is just a much higher concentration of stars. There's heaps of stars in the middle, but what we're looking at in that video is right in the very middle there, and we're seeing lots of stars orbiting around the middle. Now this is one of the big clues, or dead giveaways really, that there's a black hole, because if you follow the motions of these stars, this is a 20-year time lapse, you can actually see that they are orbiting around something that is not visible. And it's got to be something incredibly massive for all of those stars to be orbiting around it. What we're seeing here is a video that has been put together showing the actual orbits. Let me just fast forward a bit actually. So this is the orbits of all of those stars around the middle of the galaxy, around the black hole, and I'll just go forward even more actually. Let's go right in here, and you can kind of see in the middle there it's showing you where the black hole must be. So we've got enough data to be very confident that there is something enormously massive and completely dark, so it's kind of got to be a black hole really, and we've got lots of other reasons for thinking that it is there. So I'm picking this is most likely what we are going for. By the way, if you've ever been to the Space Centre and tried our VR goggles, the standard show that we have here on our virtual reality actually finishes with a simulation of what it's like to be in the centre of the galaxy there. If you haven't done that, you should definitely come and give that a blast. How's that time go? Right, what I want to do is I actually want to kind of finish up here by showing you, let me just pause that video. Let's go over here. Just bear with me a sec. What we are looking at here is it's a program called Celestia. It is a space simulator which allows us to go out in space and have a look at various things. I want to zoom in on this, and this is a black hole. It doesn't look anything like a black hole, does it? That's because the black hole is not that big white egg-shaped thing there. We need to keep moving on. This is the black hole. This is not the black hole that we've just been talking about. This isn't the one in the center of our galaxy. It's a much smaller one. But I just wanted to show you this image because you see a lot of images of black holes that look kind of like this. It's this big swirly thing with these jets pointing out the side like that. And if we zoom right into it, let's go all the way in here, that bit right in the middle, that's the black hole in there. Okay, all the rest of it is the accretion disk, and that's what I was talking about before. So an accretion disk is all that stuff swirling around and round and being sucked into the black hole, and this is one of the best ways, if not the best way, to know that you're looking at a black hole by looking at and analysing all the stuff that's swirling around and going into it. And that's the dead giveaway that there's a black hole in the middle of it. So whenever you hear people talking about the accretion disk, because that's what the photo is going to be of, most likely, is the accretion disk, it means all the stuff swirling around and going into it, kind of like water going around and around your plug hole before it goes down the plug hole. So that's what that black hole looks like. This is a kind of a black hole. It doesn't look anything like that other picture I showed you before, eh? That's because this one has a big accretion disk and it's sucking stuff into it. What stuff, you might ask? Let's zoom out. That stuff. That big egg-shaped thing next to this black hole is a star. So this is Cygnus X1. It's a real place, Cygnus X1. Actually, I'll tell you what, if you're a Rush fan, there's a couple of Rush songs, a part of a duology called Cygnus X1, and that's what this is about. It's about this black hole. Anyway, I digress. So this black hole here is sucking in that star. That entire star there will presumably eventually all get sucked into that little black hole. So they're very hungry, thirsty little beasts. So there you go, that is how it's got its accretion disk, because it's sucking stuff from the star next door. So technically that's a binary system, a star and a black hole. There you go, that is that black hole there. Have we got any other questions or anything coming in? Just a moment. Okay, so we're getting near the end of our time. Let's go back and let's talk about what happens if you should fall into a black hole, because everyone always wants to know how that works. Let's see what happens. I'll just go back to this picture over here. So this is a different type of black hole. This is one that's not sucking a whole lot of stuff into it. What we're seeing here is you can see obviously the black hole in the middle. All that stuff around it is actually light from behind it being bent around. So let's just quickly talk about what would happen if I was to fall into the black hole. So let's say that I'm falling into the black hole feet first. Getting sucked into it. The first thing that's going to happen is that the gravity on my feet is stronger than the gravity on my head. It's a thing called tidal force. So the closer you get, the gravity gets much, much stronger. That happens even on Earth. Technically speaking, the gravity on my feet right now is stronger than the gravity on my head, but it's close enough that you would never notice. When you're going into a black hole, that difference gets a lot worse, and it's actually pulling really hard on your feet compared to your head. So you can imagine what's going to happen, right? As you're falling in, you get stretched. And there's a word for that. It's called spaghettification. It's a real scientific word. Go and look it up on Wikipedia if you don't believe me. It's got its own page on Wikipedia all about spaghettification. So that's the first thing that's going to go wrong when you fall into a black hole. Now, there are some scientists that think that certain things will happen as you fall through the event horizon. Basically you burn up. A couple of other things. You will notice that time changes. This is something that we're not even going to go into really right now, but Einstein discovered that time flows at different rates. So as you're falling in, someone who is a long way from the black hole and watching you fall in, they never actually see you fall into the black hole. Time just slows down until eventually you just kind of seem to be sitting there. And what would happen is you would just sort of seem to fade away. That observer from further back would never actually see you fall in. If you're the person falling into the black hole, it's in reverse. Everything outside the black hole, if I'm sort of falling in backwards and looking at the rest of the universe out there, that would seem to speed up. So everything is getting faster and faster and faster as I fall into the black hole. But for me, time still feels the same. I would still fall into the black hole and get crushed into a little dot, which is the next thing that happens as you fall into the black hole. So nothing about that is good. There's no way to survive falling into a black hole, and once you've got past that event horizon and you've fallen in, there is absolutely no way to get out. And no, it doesn't matter how powerful your rocket is. No, you can't have someone else with a long rope outside passing you in a rope and pulling you back out. That doesn't work either. Essentially, there is absolutely no getting back out of a black hole. So with black holes, we actually understand quite a lot about them, really. It's quite surprising how much we do understand, mostly thanks to Einstein, I guess. However, what happens in the middle, we are in the dark about, so we really don't know. You will always hear people saying, talking about the singularity in the middle of the black hole. And a singularity is a very odd concept in science. And essentially it means that you've got a zero-dimensional place in space. It has no dimensions at all, where everything is infinitely heavy and you've got all sorts of infinites happening. Now, I just wanted to make one point here. You hear about the singularity in the middle of the black hole all the time. But the thing is, a singularity is a mathematical thing. According to the equations, you end up with a singularity in the middle of the black hole. But really, what's happening is that, what it means is that at that point, our calculations don't actually work anymore. All our laws of physics as we understand them break down in the middle of a black hole. Even Einstein can't really tell us what's actually there. So just because there's a mathematical singularity there doesn't mean there's a literal, actual, real singularity. The reality is, what's in the middle of a black hole, we don't know. That's the answer to that question. So maybe one day we'll figure it out. Maybe it will be a real singularity, but there's no reason to think that that's actually what is in there. So anyway, that's probably enough talking about all the black holes. Let's see, Jess, you've got something for us over there.
Karsten has said the same tidal force rips moons apart and makes them form nice rings around planets.
Thank you, Karsten. You're dead on the mark. If we go and have a look at, have we got time to do that? I just love playing with my space simulator, you see. That's what it's all about, really. Karsten is talking about if we could, what was he saying? The rings around Saturn. Look, just bear with me a moment. I just can't help myself. I've got to go and have a look at Saturn. So we're coming all the way back to our solar system. It's a long journey, so we'll get there very shortly. And there is the planet Saturn. So that's what it looks like. Beautiful planet, of course. And well known for its big spectacular rings. And Karsten is pointing out that the tidal forces will pull those moons apart. So we think, we don't really understand the formation of the rings that well. You would think we would, but we don't really understand it that well. But anyway, we believe that they have come from the breakup of smaller icy moons. And they end up with the rings there. And let's just demonstrate that by looking at one of the moons that is still there. Let's have a look at this moon. It's a small moon of Saturn. It's called Pan. It's a little icy moon. It's sort of oblong shaped, but we don't worry about that. The thing that is interesting here is where this moon is. Let's zoom out and have a look at it. You see where it is? That gap in the rings is where the moon is. If we go down below and up above, so the rings themselves are made up of millions and millions of chunks of ice. They're not solid things at all, and that moon is traveling around in that gap, and it's the moon that has made that gap. And so stuff coming out from the moons, if they've got sort of a cryovolcano or something that's shooting ice out into space, that then becomes part of the rings. So thanks, Karsten. Unfortunately, you've caused me to get sidetracked again. But anyway, that's that. So does anyone have any questions or comments about black holes? They're a fascinating subject. Anyone want to talk about them or comment or anything? No? We're all happy with that. So look, where does that leave us here? Really, I think the big question is what's going to happen in the morning? What's the photo going to look like? Where is the photo of? As I say, just to recap, that is my best guess of the kind of thing that we're going to look forward to. So we saw the accretion disk in Cygnus X1. This is what an accretion disk might look like in radio waves. So I'm picking that it's most likely going to be something a little bit like that, but perhaps just a little bit more blurry. So there we go. I think because our time is about up, unless anyone's got any other questions about the black holes, we will start thinking about wrapping it up. But did we get any entries for the competition? We did? Okay. Did any of you guys want to toss in any suggestions or anything? Okay, we've got one over here. Actually, we need to write your guy's name down. So tell you what. Sorry, what, Jess? Okay, tell you what. So what have you got over there?
Disturbing thing you have seen through your telescope that has no clear explanation.
Okay, so what is the most disturbing thing that you have seen through your telescope that has no clear explanation? So we'll make a note of that. Jess, what did you have, sorry?
I need a name for that one.
Okay, thanks. That's Wendy, isn't it? Did that one. So have you guys got something that you want to toss in as well? Anyone?
Thank you.
Don't be shy. Okay, we don't have anything at the moment. Okay then, so I tell you what, was there anything else that we needed to talk about? other than drawing the competition, I think that is pretty much everything. Let me just quickly go back through my notes here to make sure I haven't missed anything there. Okay, look, I think that will just about wrap it up. So look, thank you very much everyone for joining in. We'll do the competition in just a sec. Now, a couple of things before we go. We are working on a whole bunch of issues here with the show, including technical issues, and I have noticed tonight that for some reason my camera keeps changing colours all the time. I have noticed that. I don't know what's going on there. I'll try and sort that out. But look, if you're watching the show and you see or hear anything going wrong, please do a comment and let us know, because we can often fix it on the fly. For example, last time I found out that all our audio levels were a bit too low and we didn't really know till afterwards. But please do chip in, don't think you're interrupting or anything, and we're looking for all sorts of feedback about what we can do with the show. So we really appreciate that. Are we ready to do the draw, Jess? Okay, who would like to do the draw for us? We need... oh, we've got another option here? Okay, good on you. What have you got there?
What is the most spectacular thing you've seen through a telescope?
Ah, right. What's the most spectacular thing you've seen through a telescope? So let's just make up a name. Oh, sorry, what's your name there? Emma. So add Emma to the draw. And then what we might do is we might get... shall we get Stephanie from the audience to do the draw? Would you like to do that? Now, Stephanie, who's over there in the audience, some of you may recognise her as one of the helpers here at the Space Centre. She comes and helps a lot. She was actually here earlier today when we had a very large homeschool group in here today. Kept us very busy. So some of you might also recognise her as my mother. So thanks for coming along and supporting the team tonight, Mum. Good on you. Right, how are we going with our draw there? We're just about ready to go? Okay, we'll just bring it forward. And this is your last chance, of course, to chime in with any questions or comments. Yep, we'll just come and do the draw there. And while that happens, one other quick plea. If you can help us out publicising the show, that would be really awesome. We had some good news this week, and that we hit 200 subscribers for our YouTube channel, which is nice. We are building it up, but really it's still pretty dismal. So we really need a lot more people to be joining in. So hopefully you can help us out with that and recommend the show to people. So tonight's winner of a $25 gift voucher from the shop is Wendy. Well done, Wendy. Good on you. There you go. You come along and support us every week. Thank you very much for that. So look, there you go. I think that is all for tonight. There's one last round. There's no one else wanted to chime in with anything else. Got nothing else on social media or anything. Cool. Thank you very much, everyone. We will be back here at same time next week. And if you want to chime in with any comments or questions or suggestions for things that we should be doing, we would love to hear that. So thank you again for tuning in. Really appreciate it. We'll see you again next time.